Hi all, let us learn Strands Agents SDK in this demo. Strands Agent SDK is SDK just like LangChain to build production-ready multi-agent AI systems in few lines of code. It has features like it is a model-driven orchestration provider, model agnostic and provider agnostic. What does this mean is that the same code can work and you can just plug and play models and providers. By default, it works with Amazon Bedrock. It provides simple multi-agent primitives. So building multi-agent systems is very easy with Strands SDK. And just like I said that by default it uses Amazon Bedrock, it has a best-in-class AWS integrations. So let us start with quick start. So this is documentation of quick start. First you need to install the SDK. And for that what you will do is you initialize your Python environment and then you do this pip install strands agent. I have already done that. So let me show you in the code. I have already done that here, as you can see. Additionally, it also has separate libraries like strands agent tools and strand agents builder. We'll go one by one to them. Here there is a short description. This package is for development. These are the tool. Strand agent tools provide some community driven tools, and strand agents builder provides strand agents and tools. There is also support for MCP servers, but let us not go this demo. Now, if you are using AWS, then this section tells you about how to configure your credentials, AWS credentials. So there are four ways you can use environment variables. Provide your environment variable name should be exactly like this. AWS credential file using AWS configures. You can configure it with AWS configure command. IAM roles. If you are running on services like EC2, ECS, Lambda, then you can also have IAM roles attached to your EC2 instance, ECS containers, or Lambda. Then you can provide directly Bedrock API keys in environment variable, and then Strands agent directly pick it up from that environment variable. And this is how this quick start project setup is there. We are not going to use this method. We will use Jupyter Notebook. These are the tools that we should have used. So let us do this, install additional packages here. It is going to take some time. Meanwhile, let us go now what we are going to see here. So project setup is done, and then this is our agent.py file where a tool is displayed. What we will do is, here I have this Jupyter notebook. We will add additional code cell here, and let us paste this. Let me close this, and let us see what this code does. It uses this strands, import strain agent and tool from strands, imports built-in tools called calculator and current time from strands tools. And here there is a function which acts as a tool. So you can see here at tool decorator and letter counter. What it does is it counts occurrences of a specific letter that is given in the parameter and returns the count of that letter. And finally, there is one agent instance is created, and we have passed the tools called calculator and current time and letter counter. Calculator and current time are built-in tools provided by the Strands tool package, and letter counter is our custom tool which we have created. And finally, agent is called a message. And what is the message? Message is I have 4 requests. What is the current time right now? Calculate this number divided by other number and tell me how many letters R's are there in strawberry. So let us run that and see what is the output. And it says, I will help you with all the 3 requests. Agent returns agent result object that you can see here. Agent result object with stop present as and turn, message, role assistant, and the content of the message. Here no additional information is given, only the basic information, but you can get additional information by running this result.matrix.getSummary. This is the summary of the thinking that agent does. So let us try this. I will add one more cell here and copy paste this code which just says we are calling agent with what is the square root of 144, and then we are printing the matrix which contains the get summary call. So let us see now what happens. And here you can see that agent executed the calculator tool and it provided input was square root of 144 and result is 12. This is the thinking. This is not the, it is not contained within the agent result object, but this is the thinking of the agent, and this is we got by calling the get summary method. This makes sense because 12 into 12 is 144. Total cycles 4, total duration 4 seconds, and that you can see here it is total 5 seconds. Then cycle time, tool usage, tool use id, name, input params, and there are more. It is here listing the tools. It has used 3 tools: current time, calculator, and later. And then there is a calculation result. And finally, this is the formatted response. We have not specified any formatted response, but the agent has not agent. The model has provided formatted response here. Current time, calculator, and how many letters are in strawberry? There are 3 R's. So our basic quick start agent has performed mathematical calculation. It got the current time and ran a Python code to count the letter in the words. And agent automatically determines when to use tools based on the input query and context. Now let us go ahead with our demo. If we don't want to print all of these things, then we should remove the callback handler as mentioned here. To print debug logs in our agent, we can configure the Strands logger. Let us do that here. I will add one more additional cell here. I think we have already imported agent, so we don't have to do this. We don't also have to do this defining agent. Let us remove that and let us call this. So here you can see the output of debug log. It logs each and every action that is happening, and it finally returns hello. How can I help you today? And again the response is written contained within the agent result object that you can see. Now, as I have told before, that agent is using default provider, which is Amazon Bedrock. Strands defaults to Bedrock model provider using Cloud for Sonnet. In the model your agent is using can be retrieved by accessing model.config. So here we can just print this, and as you can see, it is US Anthropic Cloud Sonnet 4 and the date of the model release in version, and include to result status auto. So this is the model that we are using. You can specify different model in 2 ways: by passing the string model ID directly to agent constructor, and by creating a model provider instance with specific configuration using the string model ID. So here they have passed Anthropic model ID. Let us try passing something else. Here there are supported foundation model Amazon in Amazon Bedrock, and this is the model ID here. So let us see. We will use OpenAI. So let us search for OpenAI, and we will use OpenAI GPT-12b. This is region agnostic model ID. So let us configure a new agent here. We'll see agent is equal to agent, and we'll pass model is equal to model ID. Model is equal to model ID, and let us save again. Same line we can copy here, and let us see what it prints. And it prints model ID, and let us see whether it what it responds to hello. So let's say print agent hello, and we have invoked the agent, and so this is the response. This is we have used string model ID and then by creating model provider instance with specific configuration. So here we are creating Bedrock model, then we are specifying the specific model ID. So let us see how we can do that. Let me just copy paste this code. So I'm creating a Bedrock model. We have to import it, and it is there in strands.model.import. Import it, strands.model import Bedrock model. We are creating Bedrock model, and here anthropic. Let us not use this. We will this time we will use something else. So let us use llama. We need to search meta. Let us use this meta llama 8b instruct version 1.0. And we are using region as US West 2, temperature 0.3. Let's see this. How does it work? So it says configuration is this, our Bedrock line created, tools directory is this, tools modules discovered, total count this, and our agent is configured. And now let us use this to call or to provide some response. Print agent, and let us ask something else now. Today is 1st December. What is 1st December known for? Let us see what it responds. Something from history. It is checking the tools configured, formatting request, inverting model, and got response. And 1st December is known for several things like World's AIDS Day, Saint Lucas Days, Advent, International Day of Person with Diabetes disabilities, and there are so many other things it has mentioned. So this is how you can use different models on Bedrock, and we have just used Bedrock as a model provider. And there are other model provider listed here. Let us see Anthropic now as a model provider. When you use Anthropic as a model provider, you need to get the API key from Anthropic. And similarly, if you are using OpenAI as model provider, or let us say Gemini as model provider, then you have to provide those APIs keys from those providers, and it might take different parameters also, which we'll see later. Okay, so now let us go to last section of this quick start, which is capturing stream data in events. So Strands provides two main approaches to capture streaming events from agent: async iterators and callback functions. So let us check what is async iterators. So for asynchronous applications like web servers and APIs, Strands provides an async iterator approach using stream async, which is particularly useful with a sync framework like Fast API and Django channels. So here we are again defining agents, and then we have this method called process streaming response, and we call this stream async method of agent the prompt, and then what happens it returns a word by word or say token by token response, which is available as a event data object in event, and then we can print this. So let us copy this code and use this and see what happens. So I will add one more cell here. I will paste the code. We are already using agent, so we don't need to import this. This calculator is also imported. We don't need to import this. and we are configuring our agent with only calculator as our tools, and we are disabling the default callback handler. Then we are defining a method called process streaming function. What it does, we are providing a prompt here. What is 25 multiplied by 48, and explain the calculation. And then we are passing this prompt to agent's stream async method. Now, because we have mentioned here, explain the calculation, when LLM processes the prompt, it will provide its reasoning behind the result, and it will be a long response. And that is why we will see the response as a streaming response. So we will not get the entire method in one shot. LLM will respond one token at a time, not one exactly one token, maybe multiple token at a time, but it will not be a response which will come entirely in one shot. So let us run this, but before this, because we are running in Jupyter notebook, we have to change this. What we'll need to do, we will not run in as a sync.io. We'll just say await here, and we need to remove this. Now let us run this, and you see response is coming here as a like somebody is typing, right? And it is completed. So you saw that agent responded with direct calculation, but it also provided multiple different method, and finally it says 25 multiplied by 48 is equal to 1200. The next method is callback handlers. So let us try this also and see how this works. Here again we have imported logging and agent, so we'll remove this. This time we are importing shell command from tools. We are defining a logger, then define simple callback handler that logs instead of printing. So this is our method called callback handler, which is doing logger.info, and it is getting data from the arguments, and then it is logging. Current tool use, so this is the method, and then we are defining callback handler here, and then we are asking agent a question, what operating system am I using, and then it is just print only, so output will go to the logger. And let us run this command, execution preview, and I think it will not run in Jupyter notebook. If we run in normal shell command, then it will work. So let us interrupt and run this as a shell command. And, we'll define a Python file here called callback handler.py, and we will paste this code. Now let's see what happens, and I will type Python callback handler.py and see what happens. Do you want to proceed with execution? Yes. And you see agent executed tool command to find out the which operating system I am using, and then finally it responded assistant contained, and it gave the result. So this completes our quick start, and on the next step we can see examples, community supported tool, Strands agent builder, agent loop, and other things about Strands agents. Thank you very much.